Yeah, okay, guys, we can start with our module number 6, right? Data link layer, right? After module number 6, we are going to move on to module number 7. And after number 7, that we are going to start tomorrow. And you are going to write your final examination for this particular module from module 4, 5, 6, and 7. So it's gonna be basically four chapters, right? But after today's lesson, we are going to do a few practicals. And after the practical, you have to start already revising some of the practice questions from chapter 4, 5, 6, and 7, all right? Those who never wrote also last week, you are going to write today, but later, maybe after 12, right? Yeah. Data link layer, right? We spoke about the OSI model, right? How many layers for OSI model? 7 layers, right? This data link layer, in which level can we find it? Level 1, level 2, level 3, or 7? Which layer from the OSI model? Yeah, layer 2, right? So data link layer can be found in layer 2 of the OSI model, all right? And when we are talking about this layer, this data link layer, you have to see that we are going to talk about network interface card, right? So basically, we are going to discuss more about network interface card, right? Now, you have to understand the purpose of the data link layer. Why you need to understand this layer and what this layer does, right? Number one, this data link layer, oh, you cannot see properly, eh? Let me try to reduce it. So data link layer will be responsible of allowing two network interface cards to talk, right? Like you got your PC one side, there's another PC one side. Those two PCs need to talk. Those two computers need to talk, all right? But your PC will have a network interface card. My PC will have a network interface card. So the communication between those two network interface cards will be possible because of the data link layer, right? So shortly, data link layer will allow two network interface cards to talk, right? Or multiple, not only two. This is the main objective of this data link layer, number one. Number two, you remember from the OSI model, data will flow from the application, presentation, session, like transport, network, data link layer, and physical layer, right? So data link layer will make sure that protocols from the above layers to communicate with what? With the physical layer. So what does it mean? It means this. You got your OSI model, right? Like you got your data link layer, like in the middle, right? Your data link layer will allow like your network layer to talk to the physical layer, right? So, and number three, we are talking about frames, right? Frames means this. From number three, you have to understand that some data will come from network layer to data link layer, right? But from the network layer, we are talking about the IP address, right, that need to be added. When your data will move to the data link layer, your data will change the form. Your data will become what we call a frame, right? So, and that process of coming from packet to frame, we call it encapsulation. Encapsulation means like you are taking a message, you are putting it inside your envelope, right? Like when you got your letter, you have to take your letter and put your letter inside an envelope, right? In order for you to send it. So data will be sent to a particular format from the data link layer. This is the encapsulation. So shortly, it means you are taking data from the network layer and you put it to a proper format to be sent to the physical layer. And number 4, this layer will detect some errors. Suppose like data will come from the application layer up to the network layer. If there is a problem, this layer will make sure that it's going to detect that error. And when there is a problem, this layer will do what? This layer will reject the packet or the frame, right? So you don't want to be seen. Huh? So, okay. So any question? Any question, guys? Okay, we are talking about what? Data link layer, right? Data link layer can be found in layer 2 from the OSI model. So the position of data link layer is number 2, right? And when we are talking about this data link layer, we are talking about network interface card, right? We are going to be concentrate on what? On network interface card. That component, like on your laptop, that will allow you to be connected to others, right? So data link layer, we are more focalized on network interface card, right? Now the communications between those network interface card will be managed by the data link layer. So the job of this data link layer will be to make sure that network interface card can talk. Job number 1 for data link layer. So data link layer number 1 will make sure that network interface card can communicate. Number 1, all right? Number 2, all right? We spoke about it. Number 2, data link layer will make sure that data that will come from above layers will talk to physical layer properly, right? Because you got your OSI model or your TCP models, right? So data will move from the application layer, from the presentation layer, from the session layer, from the transport layer, up to the network layer, right? Now, the data link layer will make sure that all the protocols, so like all the software that are working on the network layer will talk properly to the physical layer, right? So the data link layer is like in the middle. So the data link layer will wait some of the applications from the network layer, and you'll make sure that those applications can talk properly to the physical layer. So you are like in the middle between the above layer and the lower layers. Did you understand? Number 3. Number 4, you know, when you are communicating, sometimes some errors can happen, right? So this layer will detect like there is a problem in a network, right? Maybe you cannot connect to your other friends, right? So the data link layer will detect when there is a problem. And when there is a problem, the data link layer will do what? Will reject, right? Will reject that message. So job number 1, allowing communication between network interface card. Job number 2, make sure that the above layers can communicate with lower layers. Number 3, detecting the errors and rejecting, right? Did you understand before me moving to my next slide? Any questions, guys, before moving? I will. Okay. Now, the data link layer will have what? Will have 2 sublayers, right? From the design perspective, right? So the data link layer will be split it in 2 different sublayers, right? There is what we call the LLC, right? The logical link control and the media access control, right? So the network, this data link layer will have 2 parts, 2 sublayers, right? The first one is LLC, logical link control, and the second one is media access control. There are questions they will ask you from this part also, right? So those are the 2 sublayers of what? Your data link layer. This LLC and MAC, media access control. Now you have to understand what is the job of this LLC, logical link control, and what is the job of what? MAC sublayers, because there are 2 sublayers, right? What the LLC does and what the MAC does, right? You remember that I told you that one of the job of this data link layer is to make sure that the above layers can talk to the lower layers, right? So this communication will be possible because of what? The logical link control, right? So logical link control will make sure that the above layers can talk to the lower layers, because you got the OSI model, right? You got your layers. Some of them they are up and some of them they are down. Now, when they want to talk, this LLC will make sure that the communication will be possible, right? Now, this media access control will make sure that data will be encapsulated, right? Encapsulation means this, right? You know your data will come from the network layer, right? When your data is from the network layer, we call it a packet, right? Packet means data will have its own format, right? Now, for your data to move to the data link layer, you have to change the format. Just the structure of your data will change. So we don't call it again a packet. So we are calling it what? A frame, right? Now, that process of changing the format, so we call it encapsulation, right? So I gave you an example. It's like you got a letter, right? You wanna send your letter. You cannot send your letter like this. You have to put it inside the envelope, right? Understand? So encapsulation, it means like you got your data, your packet from the network layer, but you have to put it in a specific format. You have to encapsulate it, right? Okay, let's move to the next part, right? Layer 2 standard, right? Layer 2 standard or data link standard. You know what? There are rules, right? Or regulations that those layers need to follow, right? When it comes to networking, like maybe your HP laptop, right? Your HP manufacturer, your Dell computers. So you can design your own PC, but your PC needs to follow some rules, right? Some standard in order for your PC to talk to other PCs, right? When you are designing an application, your application needs to follow some standard, some rules in order for your application to talk to other applications. So you cannot just wake up in the morning, you start your company, you said, okay, I'm gonna make my own network interface card. No, your network interface card will never talk to other network interface card because you design it by your own, by not following the standard, right? So there are some standards that we have to follow, right? Now, when it comes to logical link control, the standard, it's called what? IEEE 802.2. So it's just a document that explains what you need to do, right? In order maybe to make your own network interface card, right? Now, the code, that standard what? IEEE 802.2. You are not obliged to go there, start reading. What does it mean by no? Just to know which standard for this one, right? So whatever that we are doing, switches, like routers, like MAC addresses, and so on, they are documentations. And those documentations, we call them standard, right? And when we are talking about the second sublayer will follow three standards. IEEE 802.3 for Ethernet standard. You cannot just wake up and make your own cable, right? You cannot just make your own straight cable or your own crossover cable. There is a standard for that. There are rules that you have to follow, that all the companies, they have to follow. So that standard is called what? It's IEEE 802.3 for Ethernet standard. You are not obliged to go there and read what the standard said for now. You have just to know, like, IEEE 802.3, this is the standard of what? Ethernet. How to make crossover, how to make the coaxial cable, right? Just the rules, right? So it's just a document, but they call it what? Like standard. Like you are talking about what? Laws, code of conduct, right? So it's just a code for Ethernet. And for wireless, we do have IEEE 802.11. You have to remember this one for the exam. What is the standard for wireless? That .11 must remind you. .3 for Ethernet, .11 for wireless, .15 for Bluetooth. They are just standard and just code that talks about what you have to do for you to make your wireless communication happen, how your wireless network interface need to be done, how to configure your wireless access point. They are just standard rules. You are not obliged to go there and start reading, right? But you have to know that there is a standard, or there are standards that we have to follow, that companies are following when it comes to cabling. What is the name of that standard? IEEE 802.3. What is the standard for wireless? Right? It's IEEE 802.11. For Bluetooth, .15. So those standards, they are books where, like, all those companies, they always meet, like every year, they are discussing about the evolution of the technology when it comes to wireless, when it comes to what? To Ethernet or Bluetooth and so on. When they are done with all their discussions, they're gonna publish a document, right? And that document, we just called like IEEE 802.3 for Ethernet, .11 for wireless, and .15 for Bluetooth, right? This is what does it mean? Don't take it like Yeah. Now, there are so many organizations like around the world, right? Their job is just to make sure that all the software or protocols from data link layer can communicate properly, right? Like those, like in front of you, they are just like organizations, right? So they always do like regular meetings to discuss about data link layer protocols, how they have to talk, how they have to communicate, which type of signal you must use, frequencies, and so on, all right? Now, we are going to talk about the topologies. But before even moving to topologies, I will try to summarize whatever that I have explained now. Again, because I know some of the guys maybe missed something, right? As I said, this chapter will be concentrate on what? Data linker layer, right? And from the data link layer, you have to put your mind on what? On network interface card, right? It can be your network interface card or your wireless network interface card, right? Now, what's gonna be the job of this data link layer, right? What are some of the responsibilities of this network or data link layer? Number one, I told you that your computers will have, your phones will have what we call a physical address, MAC address, right? And those MAC address will be where? On your network interface card. Now, those network interface cards must talk, must communicate. So they are going to communicate properly because of the data link layer, right? Number one. Number two, you got so many layers. Some layers must talk to some other layers, right? Like the above layers must talk with the lower layers. How they're gonna talk? So the data link layer will make sure that the above layer will talk properly with lower layers, right? Number three also, we spoke about encapsulation. Changing your data from one format to another format, right? So that process will happen from data link layer. And your data link layer, again, will make sure that when somebody is sending you a message and you don't receive it, maybe there is what? Error, there's a problem. So data link layer will make sure that it's going to detect that error when your device is trying to communicate. Besides detecting those errors, your data link layer also will make sure that when there is a problem or a wrong data, your data link layer will reject it, will reject that particular message, right? And from this data link layer, we are talking about frame. So your data, it's called frame, right? Now, besides that, I told you that we do have two sub-layers, right? So your data link layer will have two sub-layers. The first one is the LLC, logical link control, and the second one is the media access control. Now, what is the job of the logical link control? As I told you, your layers need to talk, need to communicate. The above layers need to talk to the lower layers. This LLC will make sure that the communication will be fine, right? Media access control will allow you to encapsulate your data. So to bring your data from one format to another format, from packet to frame, right? And I told you about the standard, right? Whatever that we are doing, there are some laws, some regulations that we need to follow. There's a document for every technology that we are learning. When it comes to cabling, we call it what? Ethernet. There's a document that tells you what you need to do when it comes to cabling to Ethernet. And we call that document, or that standard, we call it IEEE 802.3. When you're gonna see that .3, it will remind you that this is the Ethernet for cabling. There's a question on that, right? Now, when it comes to wireless, you always ask, so I got my Cisco wireless. You got your telecom wireless. You got your HP wireless. How they can talk? They can talk because of what? Because there are regulations, there are rules that those devices are following, right? And there's a document that will tell you about that, the IEEE 802.11, standard for wireless. And the standard for Bluetooth is .15, all right? Now, we are going to talk about the topologies, right? So as you know, when you are designing your network and you have to implement it, there are some topologies that you have to follow, right? But what's very important, you have to understand that there is a topology for a LAN, for a local area network, and there's a topology for wide area network. When you have to connect a single building, or maybe 2 to 4 buildings, there's a topology you have to follow. And when you have to connect branches, like around the city, like around the country, like around the continent, there's a topology also that you have to follow. So there are topologies for every type of network you are going to use, right? Let's talk about LAN first. I don't know if you can see properly. Okay. So this one, LAN. Right? And we're going to talk about this one later. Let me just do it like this, right? And you remember that when we are talking about topologies, we do have a logical and a physical, right? Logical tells you how logically your network or your devices are connected, like in terms of IPs, like in terms of how data will flow from one computer and another computer, right? So this is the logical topology. And the physical topology will tell you how physically those devices are connected. So when you are designing a network, you will have like a logical part and a physical part. Logical part, you will show how the IPs will be, right? How users will be connected like to the server, how your VLANs will be, and so on. But physically, you have to show how the building will be, where the computers will be, how you are going to run your cables. So it has to show, right? So this is the difference between logical and physical, all right? Oh, there is one slide that is missing. Okay, let me start with one topologies and I will come with LAN, all right? Because I cannot see that slide, all right? Or I can just edit. Oh, it's here, but it's far. Let me change it. Okay, let's first talk about LAN topologies. When you want to design your network, but your network is a LAN, local area networks, all right? Small networks, right? There are some topologies that you have to follow, right? Like the first one, this one, it's called a star topology. Star topology means what? You will have a central device and all other components will be connected to that central device. This is what we call a star topology, this one. Right? So you have a switch and all the computers will be connected to that switch. This is a star topology. Like maybe you have the wireless access point and all the phones and laptop will be connected to what? To that wireless access point, right? You will have the benefits and some disadvantages. The advantages will be like what? It's easy, like easy to configure, right? It's easy to control. So the management will be easy because you can see whatever that's going around from your device. The security also will be fine, right? But the problem comes because when that device will die, the central device, suppose like your router got a problem, what's gonna happen? No communication anymore. The network will be down. Did you understand? Those advantages of this topology. So when you are designing your network, right? Suppose like this is your building. When you connect like everybody to a single device, you must know that I will have a problem. So if this device dies, everybody will lose what? The connections. Did you understand one of the drawbacks of this star topology? Because star topology says you are going to have a main device where every device will be connected to. But the problem comes when that device will have a problem, right? I told you about the benefit of this star topology. It's easy to configure, cheaper, security it's fine, the management it's fine because we can control everybody from that single device, but there's a drawback. When that device got a problem, everybody will lose the connectivity, right? There's also what we call the extended star topology. The extended means you got different wireless access point or switches and computers are connected to them. It's just an extended of that one. But we do have like what we call a bus topology. Bus topology means that every computer is connected to its neighbor. So one computer will be connected to two others. Did you understand? Now you're gonna form what we call there's a bus and a ring. No, I'm talking about a ring. Okay, let me first talk about a ring. A ring means that you're going to form like your computers will be connected like in a ring. That's a ring that we always use, right? So my computer will be connected to your computer. Your computer will be connected to that one. That one too will be connected to this one. This one will be connected. So we are connected like in a single circle. You understand? My computer will be connected to your computer. Your computer will be connected to this one. This one will be connected to this one. This one will be connected to this one. We are going to form like a circle. So we call it a ring topology, right? But this one, you cannot see it anymore, right? So those are the old, so you cannot see those kind of topology anymore. You're just learning about them. There's another one that we call a bus topology, right? So bus topology, it's like we are connected using a single line. It's like a line, right? Where we are connected like all of us. You are going to get 1 or 2 questions where they will ask you which one is a star topology, which one is a ring topology, which one is a bus topology. Just questions. It's not like there's calculation, or they'll just like ask you. Sometimes it can be a design, or sometimes they will tell you like computers are connected to a single device. Which topology is this one, right? This is for LAN. Now, let's say you wanna connect multiple branches. You have like FNB in Durban, like FNB Johannesburg, like FNB offices in Cape Town, and so on, right? Because you are using a single app, right? Everybody's using a single app, single website, and so on. But those websites, those apps, they are somewhere, they are saved somewhere, right? So you have first to make sure that all those branches can talk. They can be connected, right? So we call it a WAN, wide area networks, right? When we connect branches, wide area networks. Now, there are topologies that you can use here, right? So I will go to packet tracer. You're gonna understand how those topologies works. Which one I'm calling a point to point, which one I'm calling hub and spoke, and which one I'm calling mesh. Point to point means this. You got one building here, like AD Power Durban, right? Like AD Power Durban. You're gonna have a router here, right? And you got another AD Power where? In Johannesburg, right? Those two buildings. Now you wanna connect them, right? Now, because you got a router, right? By AD Power Johannesburg and a router here in Durban, you can do what? You can create a link, a single link. You can connect those two routers in order for you to make those two buildings talk. So did you understand point to point? So you got all those computers, right? Those computers are connected to some of the switches. And those switches are connected to what? To a single router, right? Now that router must be connected to Durban router in order for you to create what? A single link. You're going to create a link between those two routers. We call it a point to point, right? But that link will be virtual, maybe by using IP addresses and so on. This is the meaning of point to point, how you can connect those two branches, right? But this hub and spoke means this. Hub and spoke, you are going to have a AD Power router, right? That AD Power router from Durban will be like a hub, right? Now, all those other AD Powers from Cape Town, from PE, will be connected to that single router, right? So you have like 10 routers from 10 buildings that will be connected to a single router. So that technology, we call it hub and spoke. You can also configure that, right? So you got routers from every branch that will be connected to a single router, right? Means that you create what we call a hub and spoke topology. Did you understand, right? You're going to work for companies that will have multiple branches, multiple offices, right? You as a specialist, you will know when they say, how this computer from this building will talk to other computers. You will know, my man, it's easy, don't worry. You just finish up with your configurations here. You connect your computers from this building. You go to Durban, you travel to other places. When you are done with the connectivity there, you are going now to think, how am I going to connect them? Am I going to go for point to point, where I have to connect, where I have to create a permanent link between one building or one office to another office? Or I have to go for hub and spoke, where I have to have like one router where all those other routers from those buildings will be connected to, or I have to go for mesh topology. Mesh is the last one, right? Mesh means this. Mesh means that suppose like you have two buildings, right? Those two buildings, you connect them using, you cannot use only two routers. One router from Durban and one router from Cape Town. No, you are going to create multiple links. Why? For redundancy. If one link fails, another one will take over. This is the meaning of mesh. Mesh means, suppose like you got two computers, right? You cannot use a single link for you to connect those two computers. You can use two links for you to connect those two computers. Why? Because if one link is not working, users can be connected using another link. So you have one laptop with two network interface cards, like another laptop with two network interface cards. So you're gonna plug how many cables? Two cables. You can plug even 10. So if one cable is not working, users gonna still be using the second one. So you're gonna have routers. Those routers will have multiple links that will connect them, right? Why? Because you are trying to create availability. You don't want users to lose the connectivity. You see the way you can see those ATMs. You go there, you fetch your money, you are happy, right? They always also have problems, like internet problems, like power problems, but they got multiple links. They got multiple links. Why? Just to make sure that data will still be available. But the problem with multiple links is what? The problem with multiple links, it's a cost, money, right? This is the main issue with this mesh topology. It's the costs. You have to put budgets for you to implement this technology, but it's required, especially when you are dealing with servers. If you say my laptop or this computer will be my server, make sure that you develop different strategies. Maybe your laptop can have 3 network interface cards for cabling, and you're going to configure them in order for you to avoid what? Downtime, to avoid losing the connectivity. That's why most of the time you see that server, it's a huge computer, like a huge box. Why? Because you're gonna have double. Maybe one processor from the server, you're gonna have 10 processors, one motherboard with 10 processors, one motherboard with thousands of memories, right? So every component will be double or multiples. For a server, you cannot see one network interface card. No, maybe 10 network interface cards, right? That way you can see later on it's changing the form. You see something big, but when you switch it on, still Windows. Yeah, same things, you always create users and so on, right? But the tricky questions will come. It's when they're asking you maybe one of the system administrator doesn't want to lose the connection to the server. Which type of topology gonna use? They will give you those answers, point to point, like hub and spoke, mesh topology, right? Now you're gonna think, what is mesh topology? What is hub and spoke? You have to know that hub and spoke means many devices that will be connected to one. But if that one fails, if that one doesn't work, all those branches gonna be down. This point, if you go to point, you create a single link between those two branches. If that link like is down, means what? There is no connectivity between those two buildings. So mesh topology will do the job. But the only problem with mesh topology is what? Money, right? But as you are moving, right, later on, you are going to see that for you to make sure that your data will be available, sometimes you are going even to replicate buildings. Like this building, right? You got like computers, right? And offices and so on. You're going to have the same building like somewhere else. Why? Because if this building takes fire, users will just move one time to that other building. So that building will be like on standby, waiting a problem to happen where? On that particular building, and users will move where? To these other buildings, right? So when users are sleeping, we are sleeping nicely, we can go to the ATM, we can take our money and so on. But at the back there, this is how the technology happens. How those guys are making sure, like we can access our applications, we can access our website, we can access. Can you imagine like those moms who went to fight for their money? You remember by Capitec branches, when the system was down, they think like it's easy, just something like, but if you're an IT specialist, so you'll understand, you say, ah, guys, don't fight. These things is not a game. Sometimes you have to appreciate these guys. You have to appreciate how the system works. And so it's not easy to make these things work like 24 hours. There are so many technologies like at the back there that these guys are doing in order for those things to keep on running. But users, they don't know. They don't care. When the money is not there, they will come to you, they will fight. Right? But if they can show them how they try to build and to maintain, right? Okay, let's move to, but you understand that? Like point to point, benefit, it's easy, like cheaper, but it's not well when it comes to what? To backup. When there's a problem, you're gonna lose everything. When that link in the middle will be down, you lose the connectivity between those two branches. Hub and spoke, you have a central device that is connected to other buildings. When that central device fails, you're gonna lose the connections. Mesh is the better one, but the problem comes when you don't have money, because this mesh required what? Budget. You are going even to have what? Multiple default gateways. You see this default gateway, you are going to have maybe 3 default gateways to your wireless access point. You are going to combine later on from CCNA2. They will tell you, you see those ports from the switch. You can see them, they are 20, right? But you as a specialist, logically, you can make it 1. You see those 20? Somebody can see maybe 20 cables that are going to those switches. But logically, those 20, you're gonna make it 1. Suppose like 1 port, the maximum speed is 1 gig. So if you combine those 20, so it's gonna be what? 20 gig. All those 20 gigs, you're gonna connect them where? To a single computer. Now your computer will have what? 20 gig. You see how fast that computer will be. This is logically from the configurations, right? But a junior person cannot know all those configurations, right? You can have the same switch, same server, but their infrastructure will be slow. Why? Because they don't use all those other configurations. Now, those 20 like cables, even if 1 cable is down, users are gonna still talk. Users are gonna still access the server. Why? Because you configured what we call, sometimes you're going to see it's load balancing, right? Sometimes the work will be shared between what? Between ports, right? But how they are going to share, it's your decisions. You can configure by using MAC address. You can configure by using maybe IP addresses and so on, right? So make sure that you understand, just to understand, not how to configure. There's no question how to configure point to point from CCNA1. But from CCNA2, you're going to learn how to connect buildings, how to configure these point to point, hub and spoke, mesh topology. But for now, just to know, the questions will be focalized on what are the benefits of a point to point, right? Drawbacks or disadvantages and so on, just to know. You can see they are talking about like point to point. This is how it looks like, right? This one router, like node one, it's router 1 from this AG power, maybe Johannesburg. This other router is from Johannesburg or Durban. Now you have to connect those 2 routers by using what? Internet. One of the provider can allow you to connect what? Those 2 routers, and the communication will be done. Users from Durban can access those computers, right? There's no need for you to have 2 servers or 10 servers like everywhere. You can have servers in Durban, and people, like offices from Johannesburg can access what? Right? Like now, you can access your application, your FNB application. Maybe the application is not here. It's there in the USA, but we can access. Why? Because there's a topology behind. Maybe they are using point-to-point. Maybe they are using mesh topology. Maybe they are using hub and spoke, right? As I said, there is no magic behind how computers are connected. There's no magic behind that, all right? Some of the cables are where? Like under the sea. The sea that we can see that you go by the beach. Under there are some fiber optic cables that are there that connect this country to other countries. There are cables that are running there, like up to USA, up to Europe, right? Let's move to what we call half and full duplex communications. No need for you to know the configurations, but it's your responsibility to know what does it mean by half duplex and what does it mean by full duplex. Sometimes you can have a device. When you are reading the functionalities of that device, maybe they are saying this device is half duplex or full duplex. And what does it mean? Very easy. Half duplex means that when I'm talking, you have to keep quiet. You have to listen to me. When I'm gonna be done, you two can talk. This is half duplex. So one device must talk first. Not two devices talking at the same time, right? So if this device is half duplex, means that this device cannot send and receive at the same time. Did you understand? Sending and receiving cannot happen at the same time. This is half duplex. And some devices are working on half duplex. Like what? Like wireless access point. Wireless access point working by using what? Half duplex. And there is one of the device that we call a hub. You must know those two for the exam. Hub works by using half duplex. Means when a device will send, that device needs to wait. Not like sending and receiving at the same time. Full duplex means that that device can send and receive at the same time. Like switches, routers, all right? You have just to understand the meaning of half and full. Half, I can only send, right? Once upon a time, not like send and receiving at the same time. Like a wireless access point, and because if you are using half duplex, when the device trying to send and receive at the same time, you are going to have a problem. That device will have a problem. Now, to solve that problem, there are some of the technologies that we are going to discuss now. Right? Now, there are what we call the access control method. There are so many questions on this one. The access control method. What does it mean? It means this. You are operating on half duplex. Your device is operating on half duplex, right? Means that you can only send, not send and receive at the same time, right? Now, what's gonna happen when you are trying to send and receive at the same time, right? What your device can do, your wireless access points, when you are talking to wireless, there is a method that we are using. There's a method that a wireless access point uses. We call that method CCNA/CD, the carrier sense multiple, this one. Carrier sense multiple access with collision detection. CSMA CD for cabling and CA for wireless. Okay, let me just do, like I'm gonna add another slide for you to understand better. This one is a bit, okay. Number one, there is this one. CSMA / what? CD. This one is for what? For cabling or there's a question they'll ask you on this one. Please. Just to know, no configurations here, but I will explain slowly and you're going to understand. Right? What does it mean by CSMA? Carrier sense, multiple access, collision detection, right? Because we are using what? Half duplex, right? Suppose like I have 10 computers. Those 10 computers are connected to a device, right? But that device uses what? Half duplex, right? Means what? Means that if this computer starts sending, those other devices must do what? Must wait. Now, how my computer will know that you are sending, right? Because I have to wait for you to send. Did you understand? So two computers, we cannot send and receive at the same time because we are using half duplex, right? How my computer will know that you are sending, me, I have to wait. So I cannot also send, right? There is a technology behind that. That technology is implemented on the device. That technology, we call it what? CSMA / CD. Carrier sense, multiple access, collision detection. So what does it mean? It means that devices will listen. Your computer will detect, right? Will detect like, Tando's PC wanna send. So I have to do what? I have to wait because we are using half duplex, right? They got already a technology built in. We call it CSMA CD, carrier sense, multiple access, collision detection. So a computer will know, will sense, that way there is that word S, right? The computer will sense, your phone will sense that from the cable, like somebody wanna talk. So I have to wait because we are using half duplex. Because if I'm trying also to talk or to send, we are going to create a collision, right? Collision detection, that's C. The C means collision detection. Collision means that when two devices trying to talk at the same time, they're going to create a problem. That problem, we call it collision. Ewan, did you understand? My friend, Rihanna, or how am I gonna call you today? Did you understand? Very easy. It means this: half duplex, one computer must only send, not send and receive at the same time. Now, when we connect our computers using half duplex device, means what? Computers will start listening before sending. We start listening to hear if somebody is sending already. So when that computer will detect like somebody is sending already, that computer will do what? Will wait when you're gonna be done with your sending, right? Did you understand? And the whole technology, we call it what? CSMA, carrier sense. Carrier is like the data. Sense is like sensing, multiple access, right? That's C, it's collision. Collision means that I have to listen if there is a problem before sending. Collision means when two or multiple devices are talking at the same time, they are going to create an error, like a problem. That problem, that mistake, we call it a collision. Maybe you're gonna find a question on that. What is a collision, right? This is CD, collision detection. Device will detect the collision. This is for what? For Ethernet. For Ethernet, it's carrier sense multiple access collision detection. But if we are using wireless, we don't talk about detection, we are talking about avoidance. The D will be replaced by what? By A. So same things, but the last D will be replaced by what? By A. This one, we use it for what? For wireless. So it means that when you are connected using a wireless access point, because the wireless access point using what? Half duplex means that when my phone is sending something, that other phone needs to wait. But how that other phone will understand that I'm sending? Because there is this technology that we call carrier sense multiple access collision avoidance. This future is just a future that is already built in on your wireless access point. So every device is on wireless access point, your laptops and so on, will start listening that there's a problem. Because there's a problem, somebody's sending, I have to avoid it. This is the A. The A means avoidance. D means detection. This D is detection. This A is avoidance. Right? Did you understand? So I've learned these things maybe 20 years ago, but I never forgot about them. Even if I cannot even read it, maybe until I will die, I cannot forget about this because it's the major things that you have to know. You know why I can memorize it and understanding it? Because I don't memorize ladies' problems. No matter how I want you. Your problems, I won't gonna memorize them. I can memorize the most important stuff for me to make money. Those other small problem, conflicts, neighbors, I don't put them here. I got messages from my family maybe 2 months. My uncles, my sisters, and so on. I don't read. You know, because when you have a mouse like at your home, right? When you give your mouse like food, tomorrow that mouse will do it, will come and call others. So it's gonna become an habit, right? Yeah. Sometimes just some other people don't even read that message. Maybe you made a mistake by trying to give them some food. They will come and call others. The news will go like everywhere, like, hey, you know, there's food there. Let's go. That's why sometimes you can forget so many things. These things, I can sleep, I can wake up, I know. But from when I was like maybe 19, I kept this one, right? But I'm a real lover, so I'm a real one. So I love people so much. But I'm not skipping what they are saying or what. We can talk when I go home, I forgot. Yeah, I can laugh, serious. I can have headache for someone. Real, serious headache. I'm not even sleeping. But I'm trying my best to keep the most important things for making money, all right? This is what I'm keeping in my brain. Okay, let's move forward, all right? Did you understand? Okay, Daddy just explained because I did my own slide. The A is avoidance for wireless. So what you must know is CD, that last CD is for Ethernet, for cabling. CA for wireless. There are questions on those two. But you must know the CA for wireless, CD for cabling. Okay, I've already explained. Data link frame, as I said, when your data will be from the data link layer, we call it a frame. And that frame will have a specific structure, but there's no need for you to know it deeper. So they just want it like to inform you, like when a message is from the data link layer, that frame looks like this. So if you're a programmer, you can try to make your own frame, and so you want to understand. Okay, Every frame will be made of those three parts. There is a header. There's what we call a header, data, and a trailer. So it's just a structure of the message. When your message will move from the network layer, reach the data link layer, that message will have three parts. There's a header, there's a trailer, and there is what? Data. Did you understand? Did you understand, my friend? I will give you a break. We spoke about so many things, and tea time, it's 10:15. And we're gonna come back just for a few things and finish the chapter. I think maybe it's 3 to 4 slides left, all right?